Okay, hi everybody. So today will be a brand new video and it will also be a follow-up from the Euler series that I've done previously in my previous video. So remember in the previous video, I showed how are we able to derive the series pi square over 6 and how this value actually converges to the infinite harmonic series. All right, so if you remember from the previous video, that is also a video that is related to the Swiss mathematician in the 18th century by Leonhard Euler. So today we are going to continue with another video that is going to show you another three more series that was also discovered by Euler pertaining to the square of the harmonic series, okay, of the zeta function. All right, so I'm going to let's get dive into it. Okay, so today what are we going to show? Today our video, we are going to show how are we able to prove these three other series. It was also discovered by Euler in the 18th century. And I promise you, this is going to be very, very, very simple. Okay, so if you have not watched, oh yeah, by the way, if you have not watched the previous video on how I derive pi square over 6, all right, this series, okay, I do recommend that you go and check it out first. All right, because we need to apply this series into how are we able to prove all this. Okay, so I'm going to show everybody how are we going to solve this. Okay. All right. Just a minute. Okay. So coming back. Okay, so that is the Euler series. So let's move on. Okay, so we are going to start with the series for pi square over 6. All right. So this is what we have proven earlier. Now, what is going to happen? From this, I can actually separate up, okay, two other series. Okay, so over here, these ones over here, these are in odd numbers. It starts from 1, 3, 5, 7, okay, and 9, and so on and so forth to infinity. And I'm going to add a plus over here, followed by 1 over 2 square plus 1 over 4 square plus 1 over 6 square. These are all the even numbers. So basically what am I doing here is I'm actually just separating out the odd numbers and the even numbers. Now, I can only perform this step, right, if and only if pi square over 6, this series over here, is an absolutely convergent series, okay? So in this case, since, okay, this is an absolute convergent series, I'm able to break them up, okay, in this format. Next, what is going to happen? I'm going to remain this part here, all the odd numbers, I'm going to leave it aside first. But over here, okay, for all the even numbers, I'm going to factor out 1 over 2 square. I'm going to take this out as a factor for all these terms. So what's going to happen? Now I'm factoring out 1 over 2 square. So over here inside will be 1 over 1 square plus 1 over 2 square plus 1 over 3 square and so on and so forth. Okay, I hope you can see what I mean. Because over here, I just have to just factor it out. Okay, that's all. Now, the next step, very simple now. Okay, since we already established earlier that pi square over 6 is 1 over 1 square plus 1 over 2 square plus 1 over 3 square, so on and so forth. So do you notice over here, okay, this entire chunk of series here can converge into pi square over 6. Okay, so now I'm replacing this whole thing as pi square over 6. 1 over 2 square, okay, I'll just put it here. And all the odd terms are just remain unchanged. So very simply, now I'm going to write the whole equation now as pi square over 6, okay, is now equals to 1 over 1 square plus 1 over 3 square plus 1 over 5 square plus so on and so forth. These are all the odd numbers. Plus, since 1 over 2 square is a quarter, we have here as pi square over 6. All right, so very simple. Now I just have to shift this term over to the left, and I have 1 minus a quarter of pi square over 6, which is equals to, okay, the sum of odd number series over here. Okay, so last but not least, when I subtract 1, okay, with a quarter, I get 3/4. 3/4 of a 6, okay, 3/4 of 6 is a 8. Okay, so pi square over 8 is therefore equals to 1 over 1 square plus 1 over 3 square plus 1 over 5 square, all the respective odd numbers, all right, at the denominator. All right, so that is how I prove it. Okay, so that's very sweet and simple. All right, and that's how I derive the next series, okay, of pi square over 8. Now, coming to the next one, the second one. Now, since we have already proven what is pi square over 8, and we have also proven what is pi square over 6, all right, so we can establish these two as a fact for now, and we are going to make use of these two series to prove our third series. Okay, a third one. The third one, okay, I'm going to show you. So now I can say straight away as pi square over 6 is equals to pi square over 8 plus all the even numbers over here. Do you notice? The harmonic series with all the even numbers. So over here, what is going to happen? I'm going to, oh yeah, just in case you ask, how do I have pi square over 8 here? Because remember, pi square over 6 is all the respective positive integers. So now I'm going to use all the positive odd integers sum with all the positive even integers. Okay, and that will give us pi square over 6. So for now, right, what am I just going to do is I'm just going to substitute pi square over 8 because for all the odd integers, I just put it there. Okay, so if I put it there, over here, I'm left with only the even number integers. All right. So very simple. I'm going to just shift pi square over 8 to the left. I subtract it, and I have all the even integers. So if I just going to subtract it, it will give us sweet and simple as pi square over 24 is equals to 1 over 2 square plus 1 over 4 square plus 1 over 6 square, so on and so forth for all values of even integers. So I hope you can see what's going on over here. And thus, that is the second proof for today. All right, so now we have already proven what is pi square over 6, what is pi square over 8, and now we have proven what is pi square over 24. All right, so now last but not least, okay, I'm going to show you one last one, okay, for today. So for today's one, now we already have what is pi square over 8, pi square over 24. All right, and of course, pi square over 6. So now I'm going to prove what is pi square over 12, okay, by making use of these two facts over here. All right, so now I'm going to, very simple, I just have to subtract pi square over 8 and pi square over 24. Okay, let's subtract them. So I just subtract, all right, and on the right-hand side, I have all the positive odd integers, and over here is all the positive even integers. Okay, so I subtract. Okay, so now the next step will be, okay, by evaluating this over here on the left-hand side, I have 16 over 192 of pi squared. All right, and on the, okay, right-hand side, I have all the respective terms. Okay, so let's say over here, I have 1 over 1 square minus 1 over 2 square plus 1 over 3 square, okay, minus 1 over 4 square, so on and so forth. All right, so this is an alternating series. So this alternating series is going to converge at pi square over 12. Okay, because I just evaluate this on the left. All right, and this will give me pi square over 12. So I hope that you can see what am I trying to show here. All right, and that's it. All right, surprisingly, it was very simple in my opinion. So that is what we have today as proof. Okay, so thank you very much for watching and have a nice day. All right, so goodbye.